Scientists don't only study planets, but also their weather. And on one of the planets in the solar system, there are storms 1.3 times the diameter of Earth raging with a force that is hard to imagine. What's going on with Jupiter? And why is it so important that everything is okay with the gas giant? Our ancestors knew the monstrous size of Jupiter. The gas giant's mass is 2.5 times the total mass of all the other planets in the solar system and 37.8 times the mass of the Earth. Jupiter's volume is 1,300 times larger than our planets. But today we have advanced technologies that help us learn more about the gas giant than just its size and mass. Astronomers pay a lot of attention to the study of Jupiter, as our planet's future depends on it. The latest data we have shows that right now, something strange is happening with the planet. Jupiter is considered the super vacuum cleaner of the solar system by astronomers because of its immense gravity well and where it orbits in the inner solar system. The gas giant has taken some huge impacts from asteroids that could have hit the Earth in the past, like Shoemaker-Levy 9, which slammed into Jupiter as it broke into pieces in 1994. But the planet's gravity isn't always protecting us. Along with Venus, it affects the Earth's climate every 405,000 years. Gravitational fluctuations between Earth, Venus, and Jupiter bring us abnormally cold winters and hot summers. Droughts become severe, and rains cause floods. Researchers say we are now somewhere in the middle of this cycle, and if something goes wrong on Jupiter, it could affect Earth in a big way. So what is the weird thing going on with Jupiter? For one, its most famous storm seems to be shrinking, and we have no idea how that will affect the planet. The Great Red Spot is a huge anticyclonic storm on Jupiter. The largest storms on Earth are more than 1,600 kilometers, 1,000 miles, across, with winds reaching up to 320 kilometers per hour, 200 miles per hour, but these hurricanes pale in comparison with the Great Red Spot anticyclone, which is about 16,000 kilometers, 10,000 miles, in diameter. The gigantic storm is circling Jupiter at 650 kilometers per hour, 400 miles per hour. Astronomers discovered the Great Red Spot in the 17th century, and scientists still study this phenomenon. The distinctive color of Jupiter's Great Red Spot has been a mystery for a long time. Some scientists believe the storm is colored by complex organic compounds the whirlwind lifts from the inside of the planet into the upper layers of the atmosphere. Others think the rusty color comes from sunlight splitting up different chemicals in the anticyclone's upper atmosphere. If so, the storm isn't actually very red at all, and what we might see is just a sort of sunburn at the top of it. Another interesting question is why the anticyclone lasts so long. Scientists have suggested it's because of Jupiter's composition, which is mostly hydrogen and helium. The gas giant has no solid surface to frictionally weaken the storm. On Earth, friction reduces the wind speed near the surface, slowing down storms. But other planets in our solar system aren't like the Earth either. Saturn, for example, isn't rocky, and storms there don't last this long. The biggest storm on Saturn, the Great White Spot, covers several thousand kilometers. You can see it through a telescope as a white oval. This spot appears every 30 years, and then vanishes without any trace. The Big Dark Spot on Neptune, which was discovered in 1989, was also proved to be short-lived. The wind around the storm reached supersonic speeds of up to 2,400 kilometers per hour, 1,500 miles per hour. The large dark spot was constantly changing its shape and size. With that much activity, the storm was clearly not going to subside, and yet in 1994 it disappeared. But let's get back to the Great Red Spot. The Juno spacecraft passed over the anticyclone twice in 2019. It took images of the storm to help determine its nature. Using Juno's data, scientists compiled a three-dimensional model of Jupiter. It showed that the Great Red Spot extends much deeper than previously thought. On Earth, a storm of this size would rise above the International Space Station. Researchers say that from above, the cyclone looks like a huge pancake, but a really thick one going 500 kilometers, 310 miles, deep into the clouds of Jupiter. This is 50 to 100 times deeper than the Earth's oceans. The storm is powered by atmospheric jets that go far deeper, about 3,000 kilometers, 1,900 miles. Scientists are still trying to unravel the mechanism behind how these jets move. So far, there's only one clue from the spacecraft data. Atmospheric ammonia gas is moving up and down in the jets. This is very different from the way things happen on Earth. On our planet, atmospheric phenomena are largely driven by water clouds, condensation, and sunlight. This is what we would probably see inside the Great Red Spot if we could get there. The gravity there would be intense. The Juno spacecraft passing over the Great Red Spot was like driving a car on a road full of potholes. Radio waves reaching Earth were slightly compressed and stretched. Thanks to this effect, scientists picked up tiny tremors, 0.01 millimeters per second, and were able to calculate the gravity inside the storm. It turned out to be so strong, as if a mysterious planet was hiding at the bottom of the anticyclone. But of course, scientists didn't find any planet there, only a gas surface. Meanwhile, new measurements from the Hubble Space Telescope show that the storm has changed its form from oval to round and shrunk considerably. Previously, 3 Earths would fit inside the monstrous storm, but now only one can. Look at these Hubble telescope images from 1995, 2009, and 2014. You can see how the Great Red Spot has shrunk in just 19 years. So why is the storm on Jupiter shrinking? And do we have anything to worry about if the storm disappears? According to researchers, something in the planet's atmosphere is killing the storm. An unknown force is tearing apart the Great Red Spot. In May 2017, the Gemini North Telescope spotted a small hook-shaped cloud on the west side of the storm, and something else that looked like a wave peeling off its eastern side. The Juno spacecraft also took an image of red flakes flying away from the spot. Researchers confirmed that formations of various shapes actually detach from the Great Red Spot and scatter into space. These huge chunks, up to 100,000 kilometers, 62,000 miles, in size, are about the size of Portugal or Iceland. Computer models show this is a very natural phenomenon for Jupiter's complex atmosphere. It may happen due to the convergence of the Great Red Spot and smaller storms on Jupiter. Anticyclones are attracted to other anticyclones, and opposites such as cyclones and anticyclones repel. The merging of anticyclones is a long process that can lead to significant changes in Jupiter's atmosphere. As these smaller storms merge with the Great Red Spot, they could be contributing to its shrinkage and changing its dynamics. This convergence and subsequent interaction between anticyclones can tear pieces away from the Great Red Spot, causing it to lose mass and energy. The exact cause of the shrinkage is still unknown, but it is clear that Jupiter's atmosphere is extremely complex and dynamic. The interactions between various atmospheric phenomena can result in significant and sometimes unpredictable changes. Researchers continue to monitor the Great Red Spot using telescopes and spacecraft to gather more data and develop better models of Jupiter's atmosphere. Understanding these processes is crucial because Jupiter's gravitational influence extends far beyond its own orbit. Changes in Jupiter's atmosphere can have ripple effects throughout the solar system, potentially impacting the climate and stability of other planets, including Earth. By studying Jupiter and its weather patterns, scientists hope to gain insights into the broader mechanisms that govern planetary atmospheres and their interactions within the solar system. As we continue to observe and study Jupiter, we may uncover more about the forces at play within the Great Red Spot and how they affect the planet as a whole. This knowledge not only enhances our understanding of Jupiter, but also provides valuable information that can help us predict and prepare for potential changes in our own planet's climate and environment. The ongoing research into Jupiter's Great Red Spot is a testament to the importance of planetary science in understanding the complex and interconnected nature of our solar system.